Okay, so welcome to my talk. I'm Björn Kahl from Fraunhofer IPA here, just as my colleague Thilo. And as Dennis already said, this talk will be in a similar context, also with a different focus. So Dennis very nicely showed the current state of the tooling which is developed in ROS-I, which is an European project. I'm talking about the xeronet project, which is actually a national German project, which I typically call a sister project to ROS-I in a sense, because we look basically not so much on the modeling technology itself, we're looking more at how to make these things into, let's say, usability and the community part. This is why I actually called this here, is it working? Well, no, not. Building a community platform top-down. So you may actually wonder, a platform and top-down, does that make any sense at all? It's usually communities grow bottom-up. There's some great idea, people gather and something happens, some magic, and people just start to work together. So when we talk about platform or even use the term top-down here, so what are we actually talking about? Are we just crazy? Or what is this about? So what we're trying to do, or to phrase it in a slightly different way, what actually does platform mean? So what we're talking about, we talk about a platform. There's so many definitions of this word that we start out with just collecting some. So a platform could be a runtime platform, basically the thing where Dennis just deployed all his staff to. There's of course a platform behind that, a technology platform, some piece of software. It could be a development platform, including tooling. It could be a community platform where people just gather and discuss topics, ideas, and so on. It could be a marketplace, service, and so on. There are different words here. All this can be understood as a platform. When we talk about xeronet, we have a kind of dual or four-sided, depending on how you look at it, idea of the term of platform. So we have on one side our runtime and development platform, which is pretty much what we have seen, or based on what we have seen just in the talk before, where Dennis showed us these nice IDE and showed some real-world examples what you can do with that. In xeronet, we basically focus on the OP0A version of the runtime, but that's by no means set in stone. So we can do ROS and all the other things as well, which we are given by the smart MDS toolchain and its nice powers it has here. When we talk about runtime and development platform, we also talk about model-driven development, as shown before, and we talk about common interfaces. That will be one of the important things here. On the other side, and that's why I called it a dual platform, you're talking about community and the marketplace. What we aim for is not just having the tools, like the MDS toolchain or some certain runtime environment. We want to actually have a marketplace, just so to say, as we have Amazon or other marketplaces. Of course, much smaller. We are just a small project, not a multi-billion player. So as such, we have in our goals these marketplace, a model repository, and what we call a service broker, for lack of a better word that I found. What we talk about here, when we talk about service brokering, meaning bringing together different roles in this ecosystem which we're aiming for. We have developers, we have service providers, we have development companies, we have, of course, the end users who actually want to run a system. And all these need to be somehow brought together. I will in the next couple minutes go into these two sides. I want to start with the technical side of what we are looking into, with the left side here on the slide. Talking about this technical side, which is kind of a recap of what Dennis told us, we have at the core the simplification of development and integration. That's our goal. xeronet is supposed to be simplified development and integration on a market scale, which is not written here, but which is a key point, which distinguishes from what we just seen. So we have all the things Dennis talked about. We have the model-driven development. We have harmonized interfaces. I think Dennis only touched slightly on that. We have tool support. We have seen that in great detail. We have rich component descriptions. It was mentioned, but I want to put it here as a phrase. And we have a multi-platform, so to say, runtime. Meaning we have ROS, we have OPC-UA, and possibly other things. If we have all those things, you may wonder why I'm telling this on a ROS conference. So where's ROS here actually? Well, the point here is that xeronet is multi-architecture or multi-platform approach. We have all these other platforms in the sense of runtime environments where we have OPC-UA, for example. We have this Industry 4.0, which goes with OPC-UA and the other way around. We have, of course, ROS, which is the topic of this conference. We have Universal Robot Plus, and we have many, many, many more. I probably could put around 20 or so here. All types of platforms, both in technology sense, meaning some software system, as well as meaning some kind of a community or marketplace. There are many of those coming. Basically, in the last 3-4 years, they kind of popped up out of nowhere, many of them. And all incompatible, which is not so nice. So for xeronet, we decided we're going for OPC-UA as our platform for runtime of choice, but we also support ACE, which is the original SmartServe protocol. We support ROS, and others can be plugged in. If you want to know more about this part, don't ask me, ask Dennis. He's the expert on this framework stuff. A key point which also has been touched on before is that the strength of xeronet, again thanks to the MDS toolchain, is combining components of different frameworks in one application. Here's an example with just some name dropping, so to say. We have xeronet components, SmartServe, OPC-UA in various versions, ROS, and all this combined into one single system. Which means it no longer matters really what your default runtime is, if you are developing for ROS or SmartServe or something else. We can combine all this into one thing with one component repository holding all the stuff. About ROS integration, just a teaser for tomorrow. My colleague Nadia will talk more about ROS modeling and what can be done with legacy ROS code and model ROS code and how this all mixed together. So for now, I just want to say xeronet systems can contain ROS nodes. It can act as a ROS node. We can basically automatically translate between the different meshes formulas between these two worlds. And we can also, to a certain extent, just take existing ROS code and transform it semi-automatically into native xeronet code. But this is all more, I think, tomorrow. Now, let's switch to the other side. So when we talk about the platform, the second side of it was community. So who are our customers actually? And I used a different form here, as usually you probably see this one here. And Dennis did not disappoint me and actually showed the pyramid. So I didn't use a pyramid here. I used a different one, and to just say, okay, who are we talking about? Our customers in xeronet are actually on the topmost, and for that also on the top on the slide, the service users, those guys who actually want to build a robot application. Not just a single system, but a complete robot application. The robot and its peripheral, and probably connections to things like data warehousing and other things. Then we have, of course, as our customers, the system integrators, so all those who actually put this together, and traditionally are the only ones who are doing that. Then we have the component suppliers, which traditionally have a strong link to their integrator, or the other way around. The integrators work with specific component suppliers, and only those. And then we have, of course, other things. We have independent developers, and we have interest groups, like all the many committees in the OPC-UA Foundation who come up with these companion specifications, or those interest groups in Industrial 4.0 who specify all kind of stuff there, like this assessment administration shell and other things which exist there. So all these things, all these are actually customers on the xeronet platform. I want to bring them together to actually work in a more dynamic way than they traditionally do. I just said traditionally one system integrator has its set of component suppliers, proven ones, they know them, they know how they work together. And this basically is kind of a trap in one way. So on one side, it's of course good, you know your friends, so to say. You know what to expect from them, and you know all the pitfalls that come with their components. On the other side, you cut yourself off from all the other newcomers that may have amazing stuff to do. So what we want to do, we want to create a platform, a market platform in this case, which tries to a little bit, let's say, put more transparency in this world, to have components on this platform richly described by the technical and the so-called semantic data sheet, which then is combined into the term digital data sheet. Basically two sides of the thing. One is more for the tooling itself to do its magic, and the other one is more for the human and for our platform, which we're talking here about, for basically allowing you to identify good components, to learn beforehand what their properties are beyond their communication capabilities, and to actually have a richer source of components and still have guarantees, still have the tooling which you can use to just try out something in the model-driven part before you actually deploy it and have the system telling you this may work or not. So basically replacing chains of supply to networks of supply. That's one of the ideas that we have here. Most of that is also written down in less words on the left side here. So we have a software component repository, we have an development environment, and we have the platform as a brokerage service which brings together end users, system integrators, development services, and so on. Now, if we want to build such a platform, there is of course a dilemma if there's a new kid on the block, and that is no one usually joins an empty platform. I mean, why should you go to the xeronet platform when there is nothing? There are no components, there are no services, there are no one who seeks a robot. So why are you doing that? And this is of course a problem which we are very well aware of, and that's where the top-down unfortunately came from, because we actually targeted or tasked with the job of trying this by our funding agency. So we have to come up with an idea, and there is not so much choices. So what we are doing, we're calling for early adapters with some promises, and this promise is on one side to reduce development efforts in the long term. Unfortunately, the truth is, to do so, you need to first invest, because you first need to put your existing products, be it hardware, like laser scanner, a 3D camera, or other things, or be it software, navigation stack, a graph screen planner, or anything else. You need to basically do the modeling part first when you have some legacy code. For ROS, we tried very hard to make this automatic, and we almost are there to do this in an automatic process to a certain extent. But for the other things, not yet. So first, we need to actually get you to do that. And we were doing this with 2 rounds of paid participation. So we're actually paying you for doing the job. Meaning we have an open call from components right now running, which is open since November 14 actually, where the target audience are companies who want to have existing components, software and hardware, and are willing to add xeronet conformity, which implies Moses conformity, as is essentially the same model stuff. The mode here is that we hand out fully funded development contracts for doing so, and the goal is to get a certain set of industrial-grade components, especially software components, but also drivers for hardware on the platform. And then when we have these, we aim at a second call, which is for systems, which is supposed to start next Automatica, which is in June in Munich, for those who don't know. And the target audience there will be system integrators and end users, basically teams of these, to come to us with an idea for a new novel use of service robotics in the industrial or semi-industrial context. Also, I know service robotics and industrial in one sense, there are people who really don't like that two terms in the same sentence. We are a little bit more open there. The mode then will be partially funded R&D with the goal of pilot applications that actually show a practical use in a practical real world scenario, solving a real task. Yeah, so that's what we want to do, and the question of course is, can it work? Can we come up with the xeronet community by just pouring out some money? Well, probably money isn't the best community builder. Well, except maybe if you're fishing actually not for individuals, but for companies and other for-profit entities. So that's some hope here. And of course, when there's a need to use the tools or the technologies we have at hand here. So if there is actually some need for model-driven, for development, especially for simplifying in the long term the efforts of doing software development in robotics. Very much will depend probably on the initial uptake, if we manage to get a first set of useful components and then useful pilot applications. So can it work? We will know in about 6 months. You may ask me then again. Thanks. Any questions now I'm willing to answer?
Thank you very much for the presentation. It's kind of interesting, but I'm wondering what is the difference in between the xeronet platform and previous reports? And I'm thinking of bricks and other previous reports. What's the difference, basically? Why this is going to succeed where the others succeeded in a different way?
That's a nice way of putting it. So as it happens, I know a little bit of bricks. So I was, let's say, marginally involved in that. And what is different here is that we at least try to come technology-wise from a more industrial, let's say, focused perspective. So there's a reason why we just said we are focusing on OPC-UA as the primary middleware and the primary component model, because we think that OPC-UA is the one next big thing in industry. So that's one reason. So we're actually not trying to impose yet another framework where no one ever had heard about. Instead, we take OPC-UA and enhance it in a sense. Does it answer the question? More questions?
Enhance in what sense? That you can model it?
Pardon, sorry?
Enhance in what sense?
In the sense that you can model it, yes, which is also part of OPC-UA to some degree, of the native OPC-UA. And the other is to have the combination with other frameworks. It's seamlessly possible to combine, as we have seen by Dennis, to combine a ROS and OPC-UA thing. And we think this is also an almost unique selling point of this Moses xeronet approach.